I'm Tammy Russell, Science Facilitator for Knox County Schools, and I'm going to do a lesson today on atomic structure for our 7th grade students. This is a part of our Week 1 instruction. I'm so glad that you joined me. I do want to let you know that any resources that are referred to in this video today are available at the KCS website. You will find them located under the Student Resources tab and inside the Week 1 packet. There are also printed copies that will be available for pickup on Monday morning from 10 until noon at all of our meal distribution sites. So let's begin. Our objective for today's lesson is to review the structure of an atom, including protons, neutrons, and electrons, their placements within an atom, and their charges. A student will know they are successful when you can build an accurate Bohr model diagram of elements with an atomic number of 18 or less. Look around you. What do you see that is made up of atoms? Did you say the kitchen table? Did you say a pencil that you might be holding? Did you think about the air that you are breathing? Everything around you is made up of atoms. So what is an atom anyway? The word atom literally means unable to be cut. So an atom is the smallest particle of an element that maintains its characteristics. In other words, atoms are the basic particle from which all elements are made. I'm sure you learned about this back in the fall, but let's think about the structure of an atom. At the center of an atom is a dense nucleus containing protons and neutrons. In this diagram, this is the nucleus, and it's blown up here so that you can see the protons and the neutrons that make up that central area of an atom. Surrounding that nucleus is a cloud-like region of moving electrons. So let's think about the size and the charges of those atomic particles. We've listed the 3 things that make up an atom. How do they compare to each other? Look at the elephant in this diagram. He's making fun of the cat for being so tiny. He's saying to the cat, "You're only 4 kilograms, but I'm 8,000 kilograms. And the kitty cat responds to him, "Relevant to an elephant, I'm about the same mass as an electron is relevant to a proton." So that tells you that protons are way bigger than electrons. In fact, it takes 1,840 electrons to equal the mass of a single proton. That becomes important when we talk about atomic mass. So just remember that. What about charge? Do you remember what you learned from your teacher back in the fall about the charge of these small pieces that make up an atom? What about protons? What charge do they have? Did you say positive? They do carry a positive charge. Remember, they are located in the nucleus and they carry a positive charge. So what about neutrons? They are also located in the nucleus. What charge do they carry? They are neutral, so they don't carry any charge at all. They do have mass, but they don't carry charge. So think about all that positive charge locked up in the center of that nucleus. What charge then do you think electrons carry? The overall charge of the atom needs to equal 0 or be neutral. So electrons carry what charge? Yes, they carry negative charge. So we've talked a little bit about protons, and we also learned back in the fall that the atomic number of an element is equal to the number of protons. Look at this section of the periodic table copied from your textbook. There is more. That's just a small part of it. Here is one of the blocks represented for aluminum. It shows the various pieces that the block tells us about each element. For aluminum, the atomic number is 13. The element symbol is Al. The element name is given here, and that's aluminum. And then the atomic mass is 26.982. For our purposes, today we are going to round that, in this case, up, because 26.9 is almost 27. So that's the way you read these squares on the periodic table. So if we look at carbon, carbon has 6 protons. Each one of these elements has its own unique atomic number. So it has its unique number of protons. Carbon has 6. Helium has 2 protons, and its atomic number is 2. Calcium has 20 protons, and its atomic number is 20. So how many protons does aluminum have then? Yes, it has 13. Because all atoms have an overall charge that is neutral, the positive and negative charges need to be equal. If aluminum has 13 protons in the nucleus and they carry a positive charge, how many electrons will aluminum have? Yes, it will have 13 electrons to equal out the charge of the 13 positive protons in the nucleus. So the number of protons equals the number of electrons. So when we talk about atomic mass, remember it takes 1,840 electrons to equal the mass of just one proton or one neutron. So we don't even count electrons in atomic mass. Atomic mass actually equals the number of protons plus the number of neutrons. If most helium atoms have 2 protons and 2 neutrons, what is the atomic mass? Yes, it's 4. If most aluminum atoms have 13 protons and 14 neutrons, what is its atomic mass? Yes, it's 27. I have available for you a handout that's going to let you practice with those things we've just talked about. The first line of the handout is an example for lithium. Lithium has an atomic number of 3, which automatically means it has 3 protons and 3 electrons. The periodic table tells me that the atomic mass for lithium is 7. So if I need to know how many neutrons there are, I go up here to my hints and I look at that, and I can determine very quickly that the atomic mass is 7, the number of protons is 3, and therefore I must have 4 neutrons in a stable lithium atom. So let's look at the next line for sodium. The atomic mass of sodium is 23, and the number of protons is 11. Can you use these hints here to fill in the rest of those blanks for sodium? I'll wait just a minute. Is this what you got? If my atomic mass for sodium is 23, and I know the number of protons is 11, the number of protons is the same as the atomic number, and it's also the same as the number of electrons. So in order to get the number of neutrons, I simply had to subtract 11 from 23, and that gave me 12. See if you can complete the rest of the handout that's available to you, either in the packet that you picked up or that you have access to in the KCS website folder for week 1. All right, I'm back. As a project to kind of finish this lesson off and give you something to do that's a little fun while you're out of school, I thought I would teach you how to make Bohr models that represent atoms and the way the electrons, the protons, and the neutrons are located within an atom. So this is how that's going to work. This is a picture of an example of a Bohr model. This particular example is of the chlorine atom. The chlorine atom has an atomic number of 17. It has an atomic mass of 35, and remember, you round either up or down depending on the number to get to the nearest whole number. There are 17 protons in chlorine, there are 18 neutrons in chlorine, and 17 electrons. So, over here are your directions, and then we'll give more specific directions in a minute. Protons and neutrons, remember, are always found in the nucleus. So, we have 17 protons in this nucleus, and we have 18 neutrons in this nucleus. To place the electrons, you're always going to start in the first orbital, and that's this smallest circle, which is outside of the nucleus. It can only hold up to 2 electrons. Once you have that circle full, that orbital is full with 2, then you have to place electrons in the second orbital. This orbital can hold up to 8. If you don't have a total of 10 electrons, you won't have to put 8 in this one. And you won't be using this one at all. If you have a larger atom that you're building, you may use all 3. You'll see how this works in a minute. Once you've filled up that second orbital, then you can move to the third orbital if needed. It also holds up to 8 electrons. Chlorine, remember, has 17 electrons, so I put 2 in the first orbital. I put 8 in the second orbital, so that's a total of 10, which leaves me with 7 more electrons that need to go in this third orbital. For middle school, we will not be making Bohr models of atoms that are larger than an atomic number of 18. You'll learn more about what happens with larger atoms when you get to high school. Okay, so in the packet that you picked up or that you have access to online, there are very specific directions of how to build a Bohr model. But I wanted to show you too the kinds of materials that you can use. I just had some paper. You can use notebook paper. The lines won't bother a thing. And I needed to draw some circles. So these are the things I used to draw my circles. I used a can of chicken noodle soup that I had in the counter to make this inside circle that I did blue just because it's the nucleus, and I didn't want you to get confused between the circle that makes up the nucleus and the circles that make up the orbitals. Then the next thing I drew was this first orbital circle, and I just had my coffee mug that seemed to be about the right size, so I used that to trace around to make this first orbital. The next circle that I made is the second orbital, and I had a grapefruit, and it worked fine. My circle is not perfectly round that I traced with the grapefruit, but you know what? It doesn't matter. We are not sweating the small stuff during this time. We're just going to have some fun with Bohr models. And then I had a lid that goes to a Tupperware container or something, and I used that to make my third orbital. When it comes to trying to find things to use for the atom's particles, the pieces that make up an atom, just be creative and look around your house to see what you have. I happen to have some beads that my daughter had when she was young to make jewelry out of. I like almonds, so I have some almonds. I have some little oyster crackers. I could have used a box of Raisin Bran. I could have used some of the flakes for some pieces and some of the raisins for another piece of the atom. You can also use buttons. There are a gazillion things that you can use to create your Bohr model. So you just find things that you have easy access to. So here is an example of one of my Bohr models that I created. This particular element is carbon, and I did create a key here. So my almonds are my protons, my oyster crackers are my neutrons in this example, and then I used the little beads for my electrons. I didn't have 6 of the same color. Again, it doesn't matter. So just have fun with this and create your Bohr models this way. Now, I will say again, when I started placing my pieces, I put all of my protons and neutrons in the nucleus first, and then I started placing electrons. Always start inside that innermost circle, and you're going to place up to 2 electrons in that first orbital. If you were doing hydrogen, it only has 1 electron, and you'd only have 1 electron in that circle. So then I placed electrons in the second orbital, and so carbon has 6 electrons. I've placed 2 in the first orbital. That leaves me with 4 that go in this second orbital. And I'm done with that one because I'm out of electrons to place. And I want to check to make sure that my number of electrons equals the number of protons that I have in the nucleus, because these are stable atoms, and so the overall charge needs to be neutral. Here's another example. When you get to the bigger atoms, they may have more protons and neutrons than you can fit in your little space that you have for your nucleus. So this is a perfectly acceptable way of showing the numbers of protons and neutrons that are found in your nucleus. In this case, this particular atom has 13 protons and 14 neutrons. Remember, I have a key down here that shows me what's what. And in this one, I used oyster crackers as my electrons. I put 2 in the first orbital, which filled that up. I put 8 in the second orbital, which filled that up, and that's a total of 10. But I have 3 more electrons that I needed to place, so I put them in this third orbital. So let's see if you can remember. If this atom has 13 protons, what element do you think it represents? We've worked with this one before. Yes, it's aluminum. See how easy this is? Let me say, too, that if you have sidewalk chalk in a driveway or a sidewalk near your home and your parents want you to be out there, that's entirely up to them, then this can also be done on your driveway with sidewalk chalk. It's also fun to teach younger brothers or sisters how to build Bohr models, or teach them what you know about an atom using your Bohr model. So have some fun with this. I want you to enjoy building your Bohr models and being creative and just having some fun. Thank you for joining me. Please stay home and be safe, because we want to join you all back together as soon as we can. Thank you. Have a great day.